All right, you guys, in number 6, we are writing a recursive equation, or sometimes we call that a recursive rule for an arithmetic or geometric, oh man, I keep writing function. I really mean to say sequence there, and I will hopefully fix that before I print it, but if I don't, I'm sorry. Using function notation. And if we're really struggling with this, this seems to have been real tough for us in class. So if you are over here on the I do not yet feel confident about this continuum, I just want to tell you that's okay. And I would so much rather you at least give me just describe in words what's happening. So let's start there. Let's just look at 6A. I see a function. Gosh, I keep doing it. It's fine. It's just the function notation. I see a sequence. It is a function, but whatever. I see a sequence, and I notice that the first term in my sequence is 5, right? So like when n is 1, the value of my sequence, f of n, is 5. And then I notice that from 5 that I'm adding 7, and I deliberately use the same tables as I used up above. All right, so I'm adding 7 each time. So I'm going to maybe say that. I'm going to say my first term of the sequence is 5, and then I'm going to add 7 to previous term. Okay, I'm going to put a pin in that for just a second. So if you feel like, I really want everyone to try to write this in function notation, but if you feel like that is just going to break your brain right now, and now I promise you it won't, but if you feel like that just is overwhelming and that it's stressing you out or it's making you feel less confident about other things, that's not the end of the world. Let's just start with describing this in words. But let's think about how we can use function notation. So let's start with that statement, first term is 5. Well, in my sequence, when I talk about the first term, that's when n is 1. And what I'm trying to express is that when n is 1, f is 5. And mathematically, the most succinct way to do that is to write f of 1 equals 5. So when I say succinct, I mean the least amount of writing. So f of 1 is 5. That is equivalent to saying in words the first term is 5. And I know these aren't like great sentences, but they're just kind of thoughts. All right, so I'm starting at 5, and then I'm going to add 7 to the previous term. So I know I'm trying to get an equation. So I keep calling it a function sequence. It doesn't really matter. I'm going to add 7 to my previous term. So let's just think about it for a second. Let's say that I was thinking about the third term. I just picked 3 arbitrarily. The third term. If I think about my third term, that is f of 3. And in this case, that's the number 19. But I could represent that 19 with f of 3. So if I'm like, well, what's my previous term? Well, the thing that comes before our third term is our second term. And so my second term is f of 2. Now, I could also think of the number 2 as being the number 3 minus 1. So generally speaking, if I subtract 1 to the number here, that's going to send me back a term because I'm taking away 1 from n. That's going to cause me to be at my previous term. So the way that I can write previous term with function notation is f of n minus 1. So then if I'm going to add 7 to that, well, I just add 7 to that. All right, we're almost done. We're so close. We're right there. This is not an equation. That's the only thing that needs to change. This is an expression. An equation has an equal sign and something on the other side of the equal sign. So what does this give me? Well, this gives me f of n. So f of n, my current term, the thing I'm looking for, is my previous term plus 7. All right, there's one other common way, just because I've seen some students doing it this way in class, and it's just fine. You could also write this as f of n plus 1, meaning my next term. So if f of n is my current term, n plus 1 would be the term that comes next. Just like if I'm at my third term, my next term would be my fourth term, and I could think of that as f of 3 plus 1, or f of 4. So by adding 1, I get my next term, which means I would be starting at my current term and adding 7. These are both correct. And I think we talked about this in class. I don't want to overwhelm you, but we could generally say, like, oh, that was weird. It turned green after I started writing. I could write infinite, like there are infinite ways to express a recursive equation. I just think some of them are less common. So if I had f of n plus 5, that would be f of n plus 4 would be the term before that. Add 7 to it. So like those are all correct. You don't need to write it 3 different ways. I'll be thrilled. I'll be elated if you write it one way. And I'll still be happy if you can describe in words. Like, we'll build up to this function notation. I know it got hard really fast. All right, so we're not complete unless we have both pieces of this. You got to give your reader a starting value because you want them to be able to generate this sequence. And if they don't know where to start, they can't come up with any terms. And I said this in class too, like you could give the value f of 4 equals 26. It doesn't technically have to be f of 1, but it kind of makes sense to start with the first term if you know it. So, all right, let's look at 6b. So this is again that same table, ooh, from way back. Oh my goodness. Well, there we go. It's the same table from 5b. We're just doing recursive, not explicit. I don't know what's going on with my OneNote when I scroll. I think my computer's overheating, but we'll see what happens. Sorry if it shuts down in the middle of the video. I hope not. All right, we talked about this one already up above. We said that we observed that as n increases by 1, my sequence represented by f of n is getting multiplied by 4. And if you're like, wait, how did we do that? I did that in the video for the 5th outcome for the video before this. So you could go back and watch that, or you could just divide. Negative 128 divided by negative 32 is positive 4. All right, so if that is the pattern I'm seeing, let's first describe this. So I see my sequence, and my first, whoops, that was about to say fist. My first term is negative 2, and what's happening? Well, I'm going to multiply the previous term by 4. All right, so just like we did up above, the only thing that's different is this is geometric. If I want to show that my first term is 2, that's like, or sorry, negative 2, f of 1 is negative 2. If I'm multiplying by my previous term by 4, well, we said our previous term is generally f of n minus 1. I'm going to multiply that by 4. You could put the 4 out in front to show we're multiplying. You could write times 4, but we want to set this equal to f of n. All right, there is an explicit, or sorry, a recursive, not explicit, recursive. So remember the difference between the two. We said, sorry, my cat's meowing in the background. We said an explicit, for each, like you plug in an input, you get an output. Recursive, we have to build off the previous term. So like for me to find f of 3, I have to know what f of 2 was. And that's again why we have to give our reader somewhere to start, because they have to know where to start building. Like you gotta know where you're starting from if you're gonna build a sequence. So, all right, that is another example. All right, we looked at these tables before. So I think I'm just going to do this very quickly if that's okay with you. Again, if you're ever writing a recursive equation from a graph or an explicit, like it helps me a lot to find the table. But remember, we said that when we find, when we found that 0 value in our table, that's not part of our sequence. That's like a theoretical. So if I'm writing my table here, and we already did this in the last video, I'm just going to put a few numbers in here. Oh, would that be a 9? I want to consider this my first term. So my first term is 13. And what am I doing to get to my next term? I'm subtracting 2 from my previous term. So it's previous term minus 2. All right, let's do that with function notation. Well, to show my first term is 13, remember x is like n, y is like f of n. So that would be f of 1 equals 13. To get to my previous term, to get to my next term, I'm going to subtract 2 from my previous term. So that's, to find f of n, the thing that came before is f of n minus 1, and I just subtract 2 from that. All right, this all together, that's our recursive equation. Sometimes I use a semicolon to separate those. All right, over here, we did this table already in section 5. We found out already that when x is 1, y is 1/2. When x is 2, y is 1. When x is 3, y is 4. And we notice this pattern where we are, wait, did I make a mistake? Oh my goodness, I did make a mistake. Sorry, when x is 3, y is 2. When x is 4, y is 8. When x is 5, y is, no, oh my goodness. Y'all, my brain is just done today. I need to stop talking and writing at the same time. Okay, we notice this pattern where we're multiplying by 2. So our first term is 1/2. Sorry, I'm abbreviating. To get to my the term I want, I'm going to take my previous term and multiply by 2. So if you can't do it in function notation, do write out the words. I was just being lazy. F of 1 is 1/2. That's the same as saying my first term is 1/2. To show that to get to some new term, I'm going to take my previous term and multiply by 2. So you could write times 2, you could put the 2 out in front, and then this all together is our recursive equation in function notation. All right, I hope you're feeling better about it. Please don't, if you're not, just at least start with writing it in words.